this is what we did. We collected 40 milliliters of water in a graduated cylinder. Then we noted its initial temperature, which was 22.5 degrees Celsius. Then we measured 1 gram of sodium acetate. And then we added that sodium acetate and water into the styrofoam cups. And then we mixed that in the machine for 1 minute. And then we noted the temperature change of the mixture, which was plus 3 degrees Celsius, meaning the substance was 25.5 degrees Celsius after mixing. Then we discarded that mixture, and then we were able to plug our values into the MCAT equation. So 40 grams comes from the 40 milliliters, then the specific heat constant of water, 4.184, and then our temperature change, which was 3 degrees Celsius.
Hi,
I'm Quentin.
I'm Ava. And I'm Amanda.
And we're doing the Calorimetry Lab of sodium acetate.
And then we're going to fill the graduated cylinder to 40 milliliters. So now we're going to measure the initial temperature. Okay, so now I'm going to pour the water into this styrofoam.
Pour that in also.
And
then mix it with the magnet. So around 1 minute of shaking. So our final temperature was 25.5 degrees, and our initial temperature was 22.5 degrees. So we come up with a change of 3 degrees Celsius. And then going through the entire calculations, first we start with, we set up our equation. Q lost by sodium acetate is Q gained by water, and this is the one we were able to find in our experiment. And then so we set up their equation for the energy of H2O, and we used 40 milliliters, which translates to 40 grams, and then we used the constant 4.184 joules per 1 gram, 1 degree Celsius. And then of course you have our change of 3 degrees Celsius from the experimentation. So we're gonna multiply all these values together here. So 40 times 4.184 times 3 equals 502.08 joules. And then so we're gonna do dimensional analysis from joules to big calories. So 502.08 joules times 1 calorie, which is 4.184 joules, and then times 1 big calorie, which is 1,000 calories, will give us a value. So divide 502.08 divided by 4.184 times 1,000, which gives us a value of 0.12 big calories. And so we know change in potential energy, or H, is energy over the mass. And our mass, we used 1 gram of sodium acetate, so we put 0.12 big calories that we got. So of course when you divide by 1, we get a final of 0.12 big calories per gram. Moving on to the percent error. As you can see, our experimental was 0.12 big calories per gram, and how we found our theoretical was we used the same 40 grams times 2.5, which is the specific heat constant of sodium acetate, and we found that the theoretical change in temperature would be 8 degrees Celsius. Multiply that all together, is 800 joules, and then doing the dimensional analysis, you get 0.32 big calories per gram. And then as you can see, we plug that into the percent error equation, which gives us 62.5% error, which is quite large, and then our percent yield, as you see, is 37.5%. So now into those possible errors. First up, we assume that there was no energy lost to the surroundings and that the styrofoam cups were perfect insulators, which is incorrect. and then this results in a lower change in temperature. And then second up, we may have not waited long enough for the thermometer to read the temperature after mixing, and then this once again results in a lower change in temperature. And then as you can see, with the lower change in temperature, we had 3 degrees Celsius, and the theoretical is 8 degrees Celsius. It skews the results by very much. And then onto the back, our third possible error was the mixing machine may have poorly mixed the sodium acetate and water, or we did not let it mix long enough. And then the fourth, we also only performed one trial, so we are unsure if our received values are precise or not. And then the fifth, we may have used too little sodium acetate and too much water, so once we mixed those, the water remained very unsaturated.